Today we're going to talk a little bit about rounding, help you out with that, and estimating. But first we have to do the rounding part. So when we talk about rounding, let's just take a number here. Let's go 28,136. You have to know your place value system. So you need to know which place value each one of these guys are, because when it tells you to round, and let's just say the nearest 100, we need to know which place value, which number we're talking about. So of course we go over here, the 6 is in the 1's place, the 3 is in the 10's place, and the 1's in the 100's place. So in this case, when we're talking the 100's place, we're talking about that 1, so we're rounding that number. And of course, when we talk rounding, we're really not talking about that number, we're talking about the number that immediately follows behind it, which is that 3. Now we have that rule that says anything that is 5 and up, we'll take this number that we're rounding to a higher level, so it'll bring it up by 1, which will make it 2. If it's less than 5, it stays the same. So if we round this particular number into the 100's place, we're going to still get up 28,000. It stays as a 1 because the 3 is less than 5, and then every number that follows behind the 100's place goes to a 0. Okay, so let's take a look at if it were to actually go up. In this case, we're going to round this particular number again to the 10,000's place. Okay, so when we go to the 10,000's place, we're going to be looking at that number 2. Number directly behind it is greater than 5, which will make that 2 go up to 3. And every number behind that, or to the right, will go to 0. So when we round 28,136 to the nearest 10,000's place, we get 30,000. Now, how do we use this? Okay, this is used in our rounding, our estimating portion. So when we're talking about estimating numbers, that's how we're going to do it. Now, there's a couple things we have to know about estimating. Let's just go ahead and get this little box here again so we know that we're talking about estimating. Okay. And when we're estimating, what we're doing is basically we're going to the grocery store and we're buying things, and we want to make sure that we have enough money. Okay, and we want to come out on the long end if at all possible. Well, in math, it's not exactly like money. We may come out on the long end, we may come out on the short end of that number, but we are really, really close depending on the size of that number. And of course, the bigger the number, the more accuracy we do lose. So let's take a number. Let's take 4,126. Let's add it to 5,802. All right. And of course, left to right is top to bottom, all that good jazz. When we're estimating, there's something we have to understand, and that is one non-zero digit. All right, and that may be vocabulary that's a little off for everybody. But when we're talking one non-zero digit, we're talking a number such as this number, 4,126, and we want one digit to be not 0, and the rest of them need to be 0. So when we round that number to one non-zero digit, that number becomes 4. The 1 is less than 5, so this number now becomes 4,000. When we round this guy, 5,802, to one non-zero digit, we're talking about the 5. The 8 is greater than 5, so that 5 in the front becomes 6. Everything else becomes zeros. So here we have one non-zero digit. Again, in the 4,000, the 4 is the one non-zero digit. Everything else is. And yet we're rounding that guy. And why we do this is so we can kind of do that in our head. 4 and 6 is 10. 4,000, 6,000 is 10,000. And we can use that not only in addition, we can use it in subtraction. So in this case, we would get 10,000 minus 8,000, and we get 2,000. Now, our actual number that we get is not going to be 2,000. What our actual number should be is a number that should be relatively close to 2,000. Okay, so whatever this number is, it should be able to relate back to that 2000. And of course, we can do it in multiplication and division. It's the same way. The thing you want to remember is it is one non-zero digit.